Dear students, welcome to s.mathguru classes. So our main discussion is eigenvalues and eigenvectors. So last class one video it was given the conception of eigenvalues, how to find eigenvalues, it was given. Now let us consider the remaining problems. The eigenvalue lambda, we write lambda is called eigenvalue, characteristic root, characteristic values, then latent roots, proper roots, different names. Maximum popularly known is eigenvalues and characteristic roots or characteristic values. Find the characteristic roots of the matrix A equal to 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. Now you want to solve this problem. The characteristic equation is given by determinant A minus lambda I, this equal to 0. Determinant A minus lambda I, this is 6 minus lambda minus 2 2 minus 2 3 minus lambda minus 1 2 minus 1 3 minus lambda, this equal to 0. We get this is 0. Now we want to solve this determinant. Just we subtract lambda from diagonals, others remain same. So 6 minus lambda, if we taking, then this cancel, this into this into this. So this will be 3 minus lambda whole square minus 1 minus 2. Then this column cancel, this row cancel, this into this minus this into this. So we get minus 2 into 3 minus lambda plus 2. We get this into this into this. And plus 2 we consider, this column cancel, this row cancel, this into this minus this into this. We get 2 minus 2 minus 1 minus plus 2, 2 minus 2, 3 minus lambda, this equal to 0. This into this minus this into this. So this is 6 minus lambda A minus b whole square, then 9 minus 6 lambda plus lambda square minus 1 minus minus plus 2 minus 6 plus 2 lambda plus 2 plus 2 2 minus 6 plus 2 lambda, this equal to 0. So 6 minus lambda, this is lambda square minus 6 lambda plus 8, 9 minus 1 8 plus 2 lambda minus 4 2 lambda minus 4, this equal to 0. So we get this one. Next we get, so if we factorize this, this is 6 minus lambda, this is lambda square minus this and this 8, 4 lambda minus 2 lambda plus 8, and these 2, from this 2 common, then lambda minus 2, and here also 2, from this 2 common, we get lambda minus 2 equal to 0. This is 6 minus lambda, and from this taking lambda common, lambda minus, so this will be lambda minus 4 minus 2 common, lambda minus 4, and this is 4 lambda minus 2, 4 lambda minus 2, this equal to 0. 6 minus lambda, and from this 2 lambda minus 4 is common, then we get lambda minus 2, and here 8 lambda minus 2 this equal to 0 we get. So from these two terms lambda minus 2 is common. If we taking lambda minus 2 common, then we get here 6 minus lambda, lambda minus 4. 6 minus lambda, lambda minus 4 and plus 8. This equal to 0. This is lambda minus 2 and multiplying this 6 lambda minus 24 minus lambda square plus 4 lambda plus 8 this equal to 0. Lambda minus 2 minus lambda square plus 10 lambda this and this minus 16 this equal to 0. So taking minus sign common, if we taking minus sign common, then this will be lambda minus 2, this is lambda square minus 10 lambda plus 16 this equal to 0. This is minus lambda minus 2 and we factorize this lambda square minus this is 16, 8 lambda minus 2 lambda plus 16 this equal to 0. Lambda minus 2 taking lambda common, lambda minus 8 minus 2 common, lambda minus 8 this equal to 0. Lambda minus 2, lambda minus 8 common, lambda minus 2 equal to 0. So lambda minus 2 equal to 0, lambda minus 8 equal to 0, lambda minus 2 equal to 0. So we get lambda equal to 2, lambda equal to 8 and lambda equal to 2. So we get these are the eigenvalues. Therefore, the required eigenvalues or characteristic roots are 2, 2, 8. These are the characteristic roots or eigenvalues. This is the answer. Very interesting and very useful. Another problem. Find the eigenvalues of the matrix 2, 1, 1, 1, 2, 1, 0, 0, 1. Now solution. The characteristic equation is given by determinant a minus lambda I this equal to 0. A minus lambda I means you subtract lambda from diagonals. 2 minus lambda 1 1 1 2 minus lambda 1 0 0 1 minus lambda this equal to 0. Now this is the determinant. We can expand in this way, in this way, in this way. Result will be same. Here we get majority is 0. We expand in this way. First is plus, next minus, plus this. Directly taking 1 minus lambda. If we taking 1 minus lambda, then this cancel, this cancel. This into this into this. So we get 2 minus lambda whole square minus 1. This into this into this. If we consider this, then we get 0, minus this, then 0, and this we get this. So this will be 1 minus lambda, 4 minus 4 lambda plus lambda square minus 1 equal to 0. This is 1 minus lambda, lambda square minus 4 lambda plus 3, this equal to 0. This is 1 minus lambda, lambda square minus 3 lambda minus lambda plus 3 equal to 0. 1 minus lambda, taking lambda common, we get lambda minus 3 minus 1 common, lambda minus 3, this equal to 0, and this implies 1 minus lambda remains same, 1 minus lambda, then lambda minus 3 common, lambda minus 3 common, we get lambda minus 1, this equal to 0. From these two, lambda minus 3 common, we get lambda minus 1. So this implies 1 minus lambda equal to 0, lambda minus 3 equal to 0, lambda minus 1 equal to 0. So 1 equal to lambda, lambda equal to 3, lambda equal to 1. Therefore, the required eigenvalues are 1, 1, 3. These are the eigenvalues of the given matrix. So this is the complete solution of the given problem. We can expand another way also, answer will be same. This will be better, this is 0, 0, directly taking this, we can easily solve this. This is the answer. We consider another problem. The sum and product of the eigenvalues of the matrix A, these are respectively 7 and 7, number B 7 and 5, number C 7 and 6, and number D 7 and 8. So we have some eigenvalues, 3 eigenvalues. Then if we adding and multiplying, what will be the result? The option is given. Now solution, the characteristic equation is determinant A minus lambda I equal to 0. So this is 2 minus lambda 2 1 1, 3 minus lambda 1 1 2 2 minus lambda, this equal to 0. So we expand this, first taking 2 minus lambda, then this cancel, this into this into this. So 3 minus lambda, 2 minus lambda minus 2. Minus 2 we consider. If we taking minus 2, then this cancel, this into this into this. So 2 minus lambda minus 1. This into this minus this into this. Plus 1. Then this cancel, 2 minus 3 minus lambda, this equal to 0. This is 2 minus this, we get this one. Now 2 minus lambda remains same, this is 6 minus 3 lambda minus 2 lambda plus lambda square minus 2 minus 2 1 minus lambda and plus 1 or 1 no need to write, 2 minus 3 plus lambda, this equal to 0. So we get this one, this is 2 minus lambda, this is lambda square minus 5 lambda and plus 4, 6 minus 2 is 4, and this is 2 1 minus lambda and this is lambda minus 1, this equal to 0. So 2 minus 3 is minus 1, and this is 2 minus lambda, lambda square minus 4 lambda minus lambda plus 4. This is minus common, then plus 2 lambda minus 1. This is lambda minus 1, this equal to 0. We get this. Next, 2 minus lambda remains same, and this is lambda common, lambda minus 4 minus 1 common, lambda minus 4. We get this. and this is 3 lambda minus 1 equal to 0. 2 and 1 3, we get this. So this implies, so 2 minus lambda is remains same, 2 minus lambda remains same, and from these two terms lambda minus 4 common, we get lambda minus 1. Lambda minus 4 common and lambda minus 1 we get, and plus 3 lambda minus 1, this equal to 0. So we get this one. Next, lambda minus 1 is common, then we get 2 minus lambda, lambda minus 4 plus 3, this equal to 0. This implies lambda minus 1, this is 2 lambda minus 8 minus lambda square plus 4 lambda plus 3, this equal to 0. This one we get. This is lambda minus 1, then minus lambda square plus 6 lambda minus 5 equal to 0. Taking minus sign common, we get lambda minus 1, and here we get lambda square minus 6 lambda plus 5 equal to 0. So this is minus multiplying by my right side, and this will be cancelled, minus 1. This is lambda square minus 5 lambda minus lambda plus 5, this equal to 0. We factorize this in lower class method. Lambda minus 1, this is lambda common, we get lambda minus 5 minus 1 common, lambda minus 5, this equal to 0. So lambda minus 1, lambda minus 5, lambda minus 1 equal to 0. So we get this, and this will be lambda equal to 1, lambda equal to 5, lambda equal to 1. So these are the eigenvalues 1, 1, 5. Therefore, the eigenvalues are 1, 1, 5. These are the eigenvalues. So our requirement, sum and product of the eigenvalues. Sum of the eigenvalues, this is 1 plus 1 plus 5, this one 7. Product of the eigenvalues equal to 1 into 1 into 5, this is 5. So sum is 7, product is 5. So option is this sum 7, product 5. This is the correct option. Option B is the correct option. Sum is 7, product is 5. Therefore B, 7 and 5, this is the answer. So this is the answer. Now another shortcut method we have. If sum given, if we adding the diagonal elements, this, if we adding 2 plus 5, 2 plus 3 is 5, 5 plus 2 7. If we adding the diagonal elements, then we get the sum of the eigenvalues. Sum is 7, here also we get 7. Without calculation we can write this sum. Sum of the eigenvalues, just adding the diagonal elements, this, we get 7, and again we get here also 7. But product we have to find. So this is the complete solution of the given problem. So this type of problem is very important for engineering courses. It may be second semester or third semester or first semester, but these are most important. And BHC maths major also, these are important, eigenvalues, eigenvectors. So dear students, if this solution getting interest, then please like this video and Share the video to other friends also. Thank you.